Assalamualaikum and hi everyone. My name is Bakir Akim bin Mamazmi, my metric number 01 DKP23F1004. Today, me and my group would like to share about the illustration of double bottom tank for longitudinal and transverse framing. The second topic is illustrate whole drainage system and related structure. Assalamualaikum and hi everyone. Today, my name is Bakir Akim bin Mamazmi, my metric number 01 DKP23F1004. I will continue the presentation. So let me briefly explain the longitudinal framing system, a crucial structural design used in large ship, especially tanker and bulk carrier. In this system, the main goal is to maximize longitudinal strength, which is vital for resisting large-scale stress like hogging and sagging, caused by wave and uneven cargo distribution. Rather than relying on closely spaced transverse frame, this design uses heavy transverse frame spaced far apart, and instead place emphasis on numerous closely spaced longitudinal girder running along the length of the ship. These longitudinal members are the main stiffener of the hull and significantly enhance its stability to withstand bending force. Beneath them, we have plate floors, solid transverse members that are typically installed every 3 to 4 frames. To fill the gaps and reduce weight while maintaining strength, bracket floors are placed in between. Running through the double bottom is continuous center girder, which acts like the ship's backbone. It ties the structure together and helps evenly distribute load across the hull. This arrangement offers superior resistance to longitudinal bending, make efficient use of material, and is ideal for the structural demand of long vessel. So in summary, widely spaced transverse frame, closely spaced longitudinal girder, strategically placed floor, and a center girder, all working together to create hull that's strong, efficient, and built to last.
Assalamualaikum, my name is Amirul Hakimi bin Fadilin Oryu, and my metric number is 01 DKP23F1003. As you guys can see on the screen, the topic that I would like to explain is transverse frame double bottom. When we look at the diagram, this system is dominated by transverse floors, which are fitted at short intervals across the ship berth. This floor acts as the primary stiffness of the structure, for their main function is to resist local hull bending stress and to distribute loads evenly across the bottom of the ship. This is very important. This is very important in ensuring the hull strength and stability. So now, these transverse floors do not stand alone. By the way, they are supported longitudinally by intercostal girder, which run in the fore and aft direction. So the presence of this girder reduce the unsupported spans of the floors, enhance rigidity, and make the structure stronger against localized stress. In other words, this system improves both strength and durability, especially in resisting concentrated loads. Finally, it is important to note that transverse framing is typically used in shorter vessels, generally those lengths than 120 meters in length. So, in summary, the transverse frame double bottom.
Assalamualaikum. Today I will talk about the whole drainage system and related structures on board a bulk carrier. The bridge system is critical for removing unweighted water from cargo hold and machinery space, ensuring both safety and cargo protection. General requirement by regulation, the bridge system must be able to drain any compartment when the ship is upright or when leased up to 5 degrees. This ensures effective operation even if the ship is slightly inclined due to cargo shift offloading. Machinery space section in the engine room, at least 2 sections are required. One on the port side and one on the starboard side. One section connects to the bilge main, while the other is linked to an independent pump or ejector. Additionally, an emergency bilge suction is provided, usually connected to the largest capacity pump, such as the main cooling water pump. Structural features: each cargo hold has bilges well, usually at the aft end, both port and starboard. These wells collect water and are fitted with strum box to prevent debris from clogging the system. Non-return valve prevent water from flowing back into the holds, and remote operation valve allows safe control outside flooded space. Example arrangement for a 26,000 DWT bulk carrier. The arrangement includes a bilge main running the length of the ship, branch suction from each hold, pump in the engine room, and an overboard discharge fit with non-return device. In summary, the whole drainage system ensures that any compartment can be cleared of water quickly, safeguarding cargo, machinery, and the vessel stability. Thank you. That's all from us.